In this video, we're going to take a look at double displacement reactions and learn how to predict products for double displacement reactions. So the general equation for a double displacement reaction is, as you can see it here, AB plus CD produces CB plus AD. So what you can see is that the A and C switch spots. And in the end, C is with B and A is with D. It looks like single displacement. It's very similar. Things are switching spots. But in the end, people still have partners. They just have different partners. In single displacement, something is still alone. Somebody does not have a partner in the end. At first, somebody was single. At the end, somebody is still single. Whereas over here, nobody's single. Everyone has a partner. They just swapped who their partners were. So the first elements in each compound will switch spots. There's three main types of double displacement reactions that you could see. You could see what's called a precipitate production, where you mix two solutions together so they look all liquidy and everything's dissolved. Then when you mix them, you see these chunks of solid that form. You see this little cloudiness that appears, and that cloudiness is called the precipitate that forms. So you can see it here. You have a solution over here and a solution over here. Everything is dissolved, but as soon as you mix them together, there's a precipitate that forms. We often describe it as being a cloudy precipitate. It's actually a solid. Here too, it's cloudy, but it's actually a solid. So this is some solid that has formed. And if you wait a little bit of over time, the solid just all builds up at the bottom, almost like if you ever swam in a lake or ocean or whatever. At the bottom of the water, there's a sand there as a sort of like a precipitate. So it builds up at the bottom. So that's one type of double displacement you could see. Another type is a double displacement that produces gas. We're not really going to see that in grade 10. We're just going to focus on a precipitate one. And the third type called the neutralization. And I'll show you what neutralization is in just a little bit. So we're going to start off with the precipitate formation to see how to predict products there. And then we'll go into the neutralization after. So how do you approach a double displacement problem? The first step is perform the double displacement. So make the metals or the two first elements switch spots. So start off with that. And then to get the new compounds, just do the crisscross for both of the compounds with their new partners. And then you could balance at the end after if you'd like. Okay. Or if I tell you to. So in this example here, we have silver nitrate reacting with sodium chloride. The metals are going to switch spots. So the silver will go where the sodium is, and the sodium will go where the silver is. In other words, the silver ends up with the Cl. You have AgCl over here. And the sodium ends up with the nitrate. You have sodium nitrate over here. The formulas were determined by crisscross method. So silver, for example, is +1, and chloride is -1. That gives you AgCl. Sodium is +1, and nitrate is -1, and that gives you NaNO3. Now, this is an example of a precipitate forming. I know that because there's a solid written here. How would you know that otherwise? Well, for now, if you don't see a neutralization type of reaction, in other words, a reaction where you have a base, OH compound, reacting with an acid, something that starts with an H, but is not water. If you don't see one of those, then for now in grade 10, the reactions that we're doing that are double displacement will be the precipitate formation. How do you know which compound is your solid and which compound is your aqueous one, meaning dissolved one? So solid is your precipitate. I would generally tell you. A little trick you can use for now is that if ever you have a nitrate compound, the nitrates are always soluble. So that means they're going to be your aqueous one, and the other one would be your solid one. Okay? So this example that's written for you over here is actually this one. This is what that looks like. Okay, now we're going to try this example here. Here we have PbNO3 reacting with Ki. So first perform the double displacement. Make the metals switch spots. So K will go with NO3, and you know that K is +1, NO3 is -1. And we'll figure out the states after. And Pb will go with I. Now be careful here. Pb, you have to figure out what charge it has. Notice there's a 2 over here. So that must have been the lead 2. So we have lead 2 iodide. So it's Pb plus 2, I minus 1, crisscross it, and you get PbI2. So remember, this is not an acid-base reaction because there's no base, there's no OH compound there. So it must be one that produces a precipitate. From our trick we learned a few minutes ago or a few seconds ago, if you have a nitrate, that is aqueous. So the other one must be the solid. And that's actually the yellow precipitate that forms here. This is actually the PbI2 precipitate, which is an evidence of a chemical reaction happening. You could go and balance it if it's not balanced already. So you can put a 2 here, for example, a 2 here. And now everything should be nice and balanced. So next we're going to try this one here. You can try it on your own. The only hint I'll give you is that the compound that ends up with carbonate is going to be the precipitate. Okay, so go ahead, try it out, then unpause the video and see if you are on the right track. So again, perform the double displacement. The first two elements will switch spots. Ca will go where Na was, Na will go where Ca was. So Na will crisscross with iodide to make NaI, and then calcium will crisscross with carbonate to make calcium carbonate. Now, I said the compound that's with carbonate would be the precipitate, so hopefully you know that means this is a solid, and the other one must therefore be the aqueous. You'll always have one aqueous and one precipitate. And so here we have our calcium carbonate precipitate, which may be this over here. You have to check to see if it's balanced. It doesn't look balanced. If I put a 2 here, it's 2 sodiums, 2 sodiums, 2. Now it looks balanced like that. And so that there is doing double displacement reactions with precipitates. Now we're going to take a look at double displacement reactions that are neutralization reactions. So neutralization reaction is where you have an acid, and we'll learn about what acids are later, plus a base. They react together. They make water all the time, and then they make something called a salt. The salt is just an ionic compound. That's all it is. So salt is another word for ionic compound. When we say salt, we mean NaCl, the stuff you put on your fries when you eat it. Okay, this is just one type of salt that exists. There's other types. There's calcium chloride. That's an ionic compound that we often use on the roads as road salt. Okay, so different types of salt exist. But neutralization is always acid and base react to form salt and water. And the reason we call it neutralization is because the acid is not neutral, it's acidic. The base is not neutral, it's basic. But when you mix them together, they cancel each other out and become neutral, meaning your salt and your water are closer to neutral than the acid and base were. And there's more details on that coming soon. So how do we recognize this? Well, you'll recognize a base with OH there, and you'll recognize an acid, which basically starts with an H usually. Okay, unless it's H2O. H2O is not an acid. It's not a base either. Then what happens is the H will switch spots with the metal. So it's almost like metal switching spots again. And so the Na will go with the Cl to make NaCl. This is your salt. And the H goes with the OH to make your water. This is water. And so that is an acid-base reaction, which is also a double displacement. So we'll try one more together. Here we have an acid and a base. The H will switch spots with the metal. So sodium will go with nitrate. Remember, sodium's +1. Nitrate is -1. The salt is going to be aqueous for the most part in these type of reactions, so just put aqueous. And then we have HOH, which is simply water. That's going to be liquid. You can try the next one on your own and then check your work. So here we have H2SO4. This is an acid. Here we have a base, so acid-base reaction. The H will kick the metal out, and the metal will kick the H out, so they'll switch spots, in other words. We have calcium with sulfate. They're both 2. So CaSO4, that's our salt, that's aqueous. And then HOH plus H2O liquid. You can then go try to balance these. So for example, the first one we did on top here, it looks balanced already. It's already balanced. It's just really this one that's not balanced here. Maybe it is. Let's see. We have 1 calcium. We have 1 S, 4 O's there. So it doesn't look like we're balanced yet. I believe we have to put a 2 here. If we put a 2 there, we have 4 H's. And over here we have 2 plus 2, that's 4 H's. We have 2 plus 4, that's 6 O's. Now we have 6 O's here as well. We have 1 calcium, and we have 1 calcium here as well. So now it looks balanced. So what we've seen in this video is double displacement reactions. We saw the general equation first. We saw there's two types. We saw, well, three types, but we're only studying two types in grade 10. We saw the precipitate production and the neutralization. Essentially, if you don't see neutralization, assume precipitate production. Basically, just perform the double displacement, figure out the charge of the subscripts of the compounds using the crisscross method. And then if you have nitrates, keep them aqueous, and everything else is solid in the situations of precipitate appearing as a cloudy substance there. If there's no nitrate, I would give you some indication as to what the precipitate is. And then for acid-base reactions, as soon as you recognize the base with the OH there, the likelihood is the other substance will be an acid, which starts with the H there. You do the crisscross, you always get this ionic compound that we call salt. It's still called sodium chloride, but sodium chloride is a type of salt. Here we have sodium nitrate. Sodium nitrate is a type of salt. Here we have calcium sulfate. Calcium sulfate is a type of salt. And then the other compound produced always with acid-base reactions is our water as well. So in the next video, we're going to take up the practice problems listed below. You're going to try them out yourself first, then use the next video to check your work. And then if you understood everything there, you should be good to go. If you don't quite understand everything, review the note and then go do a few more practice problems from the worksheets.